Welcome to a TUSD Robotics production. In this lesson, you will learn how to build a 1-to-1 gear ratio in Onshape. Hi everybody, it's Mrs. Williams, and today I'm going to show you how to build a 1-to-1 gear ratio using the parts that I've already imported into Onshape for you. Okay, so let's begin. I want to start by just showing you these folders at the bottom of the screen. We have a structure folder, and inside that I have put the beam that we will use. You can see it's a 2x12 beam. If I go back to the home, I'll look at the motion folder and you will have a rubber shaft collar, a spur gear that has 36 teeth, a spur gear with 60 teeth, a spur gear with 12 teeth, and then the pitch shaft, which I also call an axle in this video. So we're going to use the 36 tooth gears, but I have other gears in here when we do the gear ratios that are not 1-to-1. So those are sitting there waiting for our next lesson. All right, if I go back to the home, you will see that in the electronics folder, there is a smart motor. And the smart motor, you will see, has some holes on the back side of it. Oh, let me turn it around here. You will see it has some holes on the back side of it. These holes are what we will constrain to the holes on the beam, but this one is different. This is a square hole. This is actually where the axle or the pitch shaft will be inserted. And so because the pitch shaft is square and this hole is square, when this motor turns in a clockwise or counterclockwise direction, the axle will spin. Okay, so let's go ahead and go back to the home. You can see we have all of these folders that I have put the different parts into. And then the CAD imports are all of the parts, but you actually don't even need to use these folders at all. They're just storage. And we will insert each part into an assembly. Now in your file, if you have not done so already, you need to make a copy. If you're on a computer, you're going to go up, it should say make a copy somewhere around here at the top. And then you need to make an assembly file. It does not come with an assembly file. So to make an assembly file, you're going to tap or click the plus sign here, and then you're going to click Create Assembly. And it will name it for you, Assembly 1 or Assembly 2. It's up to you. I don't need two assemblies, so I'm just going to actually right-click and delete this one. So you'll probably have, oops, it looks like it went back to the motion folder. Click Home so I can see my main folders here and Assembly 1. So in Assembly 1, you will notice that there's a dot in the middle of the screen. This is the center of your workspace. I'm going to start by inserting the beam. So I go to the Insert menu in the top left corner, and I go through my parts, and I'm going to insert the 2x12 beam. I'm going to click on my workspace to place it, and check mark to accept. Okay, now I actually want this side right here to be the front. So I need to move it a little bit. And I want it to be the front to match this view cube. So I'm going to click on the part to select it, and then I get these arrows to move just that part. I'm going to use this back arrow. You see that dot right there? I'm going to use that to lift up that part so that this now is the front. It matches the view cube. This is the top. This is the right. Now I want this part to always come back to this home position in the isometric view. So I'm going to come over to the part that was just inserted over here. It looks like it's part number 2282500-026. You can rename this if you want by just right-clicking, and you can go to rename, which is, let's see, I guess it's in properties. So you can do this if you want. You don't need to, but it might help you organize what is in your list along the side. There we go, 2x12 beam. So now I know what part it is. So you can change the name in the properties window. Okay, so one thing you want to do with this part, whether you renamed it or not, it doesn't matter, but you want to fix it so that every time you go to this isometric view, it comes back to this position. So I'm going to go over to the part that I just inserted. I'm going to right click, and then I'm going to go down to Fix. And I'm going to click this Fix so that you'll see this little symbol. This means the part is fixed. So this will always be glued in this position with the view cube. So if I rotate it like this and I go isometric, it's going to come back to that fixed position. Now I'm going to build everything off of this beam, so anything that's constrained to this beam will also move with it. Okay, so the first thing I want to put in is the pitch shaft or the axle. So I'm going to insert, I'm going to look for that pitch shaft 4x, which is just the length of it. Click on it to put it in my workspace and check mark to accept. Okay, so with the axle, I often use the top of the axle right here to constrain to one of the holes because I can get a nice circle center point at the end. And then I need to decide which hole I'm going to put this in. Now, this is the one where my motor will be attached to make the driver gear. So I'm going to actually choose, I think I'm going to choose this fourth hole down to give enough room for my motor on the back side here. So I'm going to use the Revolute mate because this axle is going to spin in this hole. So I'm going to go up to my mate menu at the top. I'm going to click on the Revolute mate. And then I'm going to zoom in and I want the top of this axle, that center point. That's actually highlighted the line. I don't want the line. I might even need to move it a little bit. I want this center point right there of my axle. I'm going to click on that to select it. You will see that one of the parts has been selected. Zoom back out, kind of rotate it. Actually, I'm just going to go to isometric so it makes it easy. Perfect. All right, so now I'm going to go to the fourth hole in. 1, 2, 3, 4. Zoom in a little bit. I want that center point. Click to select, and it looks pretty good. Looks like it's centered in that hole perfectly. If it's not centered, it means you did not pick a center point and you picked probably a line or a corner or something like that. So you might have to redo it if you aren't seeing that it's centered in that hole. So I'm going to check mark to accept, and it looks pretty good. Now, one thing with the computer is that whenever you accept a mate, another mate window opens. It looks like it's underneath that mate. I don't actually use that, so I'm going to close out this extra window just like that. Okay, now if I go back to the isometric view or I zoom out a little bit, you'll see that I need this axle to go through the beam a little bit more. So it's right there at the edge. I need to push it through so that a little comes out over here to go into the motor. So in order to do this, I'm going to reopen that mate that I just made by right-clicking and editing. And now I'm going to offset it. So offset means it's going to move it to the right or the left on this is giving you the Z axis as your only option because it's a Revolute mate. And I'm going to see what 1 inch does. All right, that is actually too far. So I'm going to let's try 0.5. We just want a little bit sticking out to fit into the motor. That looks perfect, just like that. So this little end will stick out and go into the motor. I'm going to check mark to accept. That looks great. Okay, let me go back to my isometric view so that it is centered and we can insert our next part. Okay, so now I'm going to go to the insert menu and I'm actually going to add the motor next so we can make the driver gear. Now you don't see it in your list because it's a composite part, which means it's the way I imported it. There's multiple parts together. So I need to click on this icon right here for the composite part and the motor will appear. So now I'm going to click on this smart motor. I'm going to insert it into my workspace and check mark to accept. Now I'm going to zoom out a little bit. That motor's pretty big. And if I flip it around, you can see that I want the axle here. So this is going to be actually flipped. So let me flip it around to make it a little bit easier. I'm going to select the part and I'm actually going to flip it around like this to make it a little bit easier to understand. Oh, and I think I actually want to flip it around like this because that's actually how I'm going to put it on, like right like this, so that axle goes into this hole. So sometimes if you rotate your parts, it's a little easier to see what you're constraining. Okay, so I'm going to constrain this hole right that's going to be beneath the axle on the other side. So this hole right here, I'm actually going to do it on the other side though, so that it's flush with this hole. So I'm going to use a fastener mate. Now normally you might fasten this axle into this square hole, but in CAD this actually doesn't work very well. I've tried it before. So we're going to actually just do this hole onto the back side of this hole. So let's go to the fastener mate. I'm going to choose this hole right here, the center of that hole. That looks good. There we go. There we go. It selected it. Now I'm going to flip over my beam, zoom out a little bit. Remember, point your mouse where you want to go. And I'm going to use this hole right here, which is right above the axle. Let me see if I can get a better, there we go, that top of the hole right there. And I can't really see what's going on, so I'm going to check mark to accept. Just hit that isometric, and it looks really good. So the motor is, it might actually need to be offset just slightly. It's overlapping there. Let me go ahead and fix that. It's probably not necessary. It looks pretty good, but just to make it perfect. I'm going to close out this extra fastener mate that just opened. I keep telling you that it does that. Let's go ahead and close that out. This is the fastener mate we just did with the motor. So I'm going to right click and open it up to edit. And I'm going to offset it. That's the Z axis. I'm just going to see what 0.1 does. Okay, it goes in the wrong direction, so it needs to be negative 0.1. And that actually looks like it's almost too much. So you probably don't need to do this. I'm going to do negative 0.05. Probably not worth it. What does it not like here? Oh, I have 2 decimals. It gives you a red error if it doesn't like it. All right, check mark to accept. I'm going to call that done. You can see that there's no overlap. So this is really what it would look like in real life. All right, I'm going to go back to my isometric view. So now we have a motor attached to this axle. So whatever gear we put on this axle is the driver gear, because there's a motor that's spinning this axle. We call it the driver. So let's go ahead and insert our gear, which will be the 36 tooth spur gear. I'm going to go ahead and place it in my workspace and check mark to accept. Okay, we're going to use the fastener mate because we don't want this to revolve on the axle. The only thing we want to spin is this axle. So I'm going to go ahead and use the fastener mate, and I'm going to use the end of that axle again. Zoom in to get that nice center point. That whole circle is highlighted. Click on that to select. And then I'm also going to do the center of this. Now it's kind of hard to see, so I'm going to rotate it. I'm going to go in. I'm trying to find that center of that hole. That looks pretty good. That whole circle is highlighted. Let me find it. That looks pretty good, I think, right there. Check mark to accept. If it doesn't work, you can just delete and redo it. Okay, and check mark. Let's see what that looks like. Okay, pretty good. It needs to definitely be offset. We want this gear to be close to the beam so it doesn't slip around. So let's go ahead and reopen that fastener mate. Right click, edit, and I'm going to offset this one. It's the Z axis. You can see the blue Z line right here. Let's see what 1 inch does. Okay, it's pretty good, going in the right direction. Let me try 1.5. That's a little too much. Let me try 1.3. Let me look. Probably could go in a little bit more. I'm going to do 1.4. Oh, that looks pretty good. I say that works. I'm going to be very picky, and I'm going to do 1.35. Okay, that actually gives a little bit of room so there's no friction between the gear and the beam. You don't want it so close that it is too tight and won't turn, but you want it close enough so it's not going to move around. Check mark to accept. Now the next thing I need to do is make sure this doesn't come off the axle, so I'm going to put a shaft collar to hold it in place. So let's go ahead and insert the rubber shaft collar. I'm going to place it in the workspace and check mark to accept. And I'm going to use the fastener mate again. I'm going to use the circle at the end of that axle once again. And now I'm actually going to rotate this a little bit. I want the center of that rubber shaft collar. That looks pretty good. The whole thing is, we don't want the half circle. I want the whole circle highlighted so it's the center point. That will work right there. Check mark to accept. I'm sorry. There we go. I needed to click it to select it. Now check mark to accept. Okay, looks pretty good, but we definitely need to offset to move it down towards the gear. I'm just going to go ahead and reopen that fastener mate that we just made. And I'm going to offset it again on the Z axis. You can see the blue line is the Z of that axle. Let's try with our 1 again. Looks pretty good. I think we need to do 1.1. We want it to be nice and close to that gear. Oh, that's perfect. See how there's just barely any space? Check mark to accept. All right, isometric view. We have our first gear added on. It's held in place by a shaft collar, and this is our driver gear. Okay, time to put the driven gear on. So let's go ahead and insert another shaft collar. I'm sorry, another pitch shaft or axle. And I'm going to go ahead and place this in. And I think it's going to go through this hole right here. You can take a gear. I'm going to put the next spur gear in this workspace as well, the 36 tooth. Place that as well. I just want to kind of measure with it and check mark to accept. So you can actually insert more than one part at a time. I'm going to select this gear. I'm going to move it over here. And I'm also going to move it up to kind of see where it's going to go. So I'm going to try and place it so that it is about right here. I'm trying to see what hole that would be. So it looks like it needs to go up a little bit more, about right there. So I can see that it's 2 holes from the motor. If I flip this back around, it's going to be 2 holes in. 1, 2. The axle's going to go right there. Okay, let me go back to my isometric view. I'm actually going to move this gear out of the way. All right, so I'm going to click the white space to deselect the part. Now I'm going to go to the revolute mate because we're going to revolute with a mate to get this to spin in that hole. So I'm going to click the revolute mate constraint. I'm going to go to the top of this pitch shaft or axle, click on the circle center point at the top, and then I'm going to come here and I'm going to do this circle right here that we just measured. It looks good, but I know I'm going to offset, so I'm just going to do it while this window's open. I'm going to offset this. I think it only needs about a 1/2 inch, 0.5, and that looks perfect, 0.5, check mark to accept. All right, back to my isometric view to home it and center it. Okay, now we're going to put the next gear onto this axle. So I'm going to use the fastener mate. I'm going to again get the end of this axle right here, the center point. Let me zoom out. I want the center hole of this gear. Let me zoom in a little bit. Right there looks pretty good. Select, check mark to accept so I can see what's going on, and isometric view. Okay, looks pretty good, but we need to offset this to make it mesh. The teeth need to mesh together. So let me go ahead and reopen that fastener mate. I'm going to edit and offset it on the Z. Let's try 0.5. I think we did a little more than that. Okay, so let's do, I think it was 1.1 that we did. Okay, looks pretty good there. Looks like I could go a little bit more. You want them perfectly meshed up, so I'm going to do 1.15. Now your numbers might be a little bit different, and that's perfectly fine. You just need to kind of figure out what works for you. All right, that looks really good. You know, the one thing is that these teeth aren't meshing perfectly, and I don't know if I'm going to be able to fix that. I could try and rotate on the axis with this little feature right here, the reorient secondary axis, but that doesn't seem to be doing anything. I think we're just gonna have to leave it like that. All right, check mark to accept. The teeth are not perfectly lined up. That would be what we would want them to look like. So I don't know if it'll stay like that, but so we have a 1-to-1 gear ratio. We have the driver gear attached to the motor and the driven gear attached to the axle, but we need some shaft collars to hold it on. So we're going to insert, I'm going to insert 2 because we actually need one that goes on this side and we need one that goes on this side of that shaft collar to hold it in place. All right, check mark to accept. I'm going to rotate this. I think you should probably have an idea of what we're going to do now. Fastener mate. I'm going to zoom in, center point of that axle, and center point of this shaft collar of that top hole. That works right there. There we go. And check mark to accept. Okay, let me get centered with my isometric view. I definitely need to offset it, bring it down. So I will right click to edit. And I'm going to offset about 1 inch. I always forget what I've done. A little bit more. Let's try I think it was 1.15. Oh, I need more than that. Oh, it doesn't like what I did. There we go. Oops. That red is a nice sign that shows that it doesn't like what you did. There we go, 1.15 inch. That looks perfect. Check mark to accept. All right, now I need one on the back side. So I will do the fastener mate, the center point on the top of that back side of the axle, center point right here on this shaft collar, and I think that's pretty good. Check mark to accept. We could offset a little bit to get that down if you want to just be perfect there. I'm going to offset that. I think I need to go backwards, but we'll see. Let me just try. Negative, well, let's try 0.1 first. Oh, it went the right way. If it went the wrong way, you would do a negative 0.1. All right, that looks good. Let me go back to my isometric view, and it looks like the gear is going to stay on just fine. Now, if I animate this revolute mate, you'll see what happens here. So here's our first revolute mate. If I right click and go to animate and push play, you will see that only one gear spins. And that's because Onshape doesn't know that there's a gear ratio here. So I'm going to stop this, close it out, and I need to make a gear relation tool, or I'm going to use the gear relation tool to tell Onshape how these two relate. Now, we're going to use a 1-to-1 gear ratio because the gears are the same size. So I'm going to go up here where you see the little gears. I'm going to use the gear relation tool, and I'm going to choose the two revolute mates that have a 1-to-1 ratio. So I'm going to come over here and choose the first revolute mate. There you go, you see it selected. And then I'm going to choose the second revolute mate and check mark to, oh, before I do that, here's the gear relation, it's 1. Okay, if a gear goes in the wrong direction, you can reverse a direction of the gear. But let's see what it looks like. Check mark to accept. Now I'm going to animate this first one. Right click, go to animate, push play, and notice that they go together. And they're actually spinning properly. One goes to the right while the other one goes to the left. So the direction of the gears change when they're meshed together. If both of your gears are going the same way, just check that box that said reverse gear, and it should look like this. So that is the end of our 1-to-1 gear relation or ratio lesson. Congratulations, you have made another CAD assembly in Onshape.